Alright, so we did vector addition, we did the drawing. I want to find out now how to do this by calculations. This vector is going west, so I'm going to put down here for vector A that it is negative 12 in the west. It is not going north or south. No work to show because it's just going west, so that's all you do. Whereas vector C is going south, so I come down to vector C and I'm going to put negative 3 in the south and 0 in the east and west because it is not going east or west. But vector B is going southeast, so it's going two different things, which is weird. So I'm going to draw a south and an east vector components. Now I can measure those with a ruler, and I can see that the east is about 2.9, all right, east, whereas the south is about 2.7 south. So I kind of put it over here, right? Here's the south for vector B, and here it is for vector B in the east. Now, so that tells me I know it's negative and a positive. But the way we actually do this is by saying that I'm going to take this angle next to where vector B started, and that angle right here, because this is 270 degrees south, and this is at 315 right here, right? Vector B is 315. I can just take 315 minus 270, and that's going to give me 45 degrees. Now, because I know it's 45 degrees, I can find this side over here, which is the opposite side. So the east is the opposite side, and opposite equals h times the sine of theta, just like it shows you right there. And over here, right, this side would be the adjacent. So this is adjacent, which equals h times the cosine of theta. So what is h? H is the hypotenuse. Well, how big was this hypotenuse? This hypotenuse was, well, how long was it? It was 4. So I'm going to go ahead and write in that the hypotenuse was 4, and the cosine of, well, how did I know that was adjacent? Because it was adjacent to this angle of 45. Over here, this opposite, well, it's the same triangle, so the hypotenuse is always the longest one, so it's still 4. And it's a sine of 45. Because how do I know this is opposite? Because it's opposite of this 45-degree triangle. All right, so now that I've got those numbers, I can go ahead and plug that into my calculator. All right, key thing is to make sure that when you're plugging this to your calculator that your mode, right, is going to go ahead and not be in radians. It's got to be in degrees. All right, so now we got that. I'm going to go ahead and plug in, right, that the 4 times the cosine of 45. And that equals 2.83. So 2.83. So this is 2.83, which I had a negative 2.7, pretty close. And then over here, nice thing about this, if you plug this in, you'll find out that it gives you the exact same number. Anytime you've got yourself a 45-degree triangle, that means both sides will go ahead and end up being the same value. So now that I have that, all I have to do is add this column up, and I end up with a negative 5.83. Why did I do it in red? Well, because that's basically telling me how far south I went for my red resultant. And then over here, right, this one, I have to do a negative 12 plus a 2.83, and I get, oops, I had to answer in there. So 12, right, or a negative 12, plus a 2.83, and I get negative 9.17. So what does that tell me? That tells me that since this is 5.83 and it's negative, that means how far south I went. So if I were to measure 5.83, I would see that that is going to go ahead and head down to about there, which is about as far south as my resultant. And then I'm going to go ahead and end up going over, right? Let's see, whoops. Right there, if I measure that, right, that is basically 9.17, right? Going over to right there to the tip. So in other words, these things just gave me what these values are. So this is a negative 5.83, and this one's a negative 9.17. Now that I have myself a nice right triangle from taking all this information and turning it into one big right triangle, I can go ahead and use these numbers, Pythagum, to find the resultant. So I end up taking square root of 5.83 squared plus, my bracket, and then 9.17 squared. Okay, plug that in my calculator, and I'm going to go ahead and get 5.83 bracket squared plus bracket 9.17 bracket squared. And I get 10.86 or 10.87 when I round. 10.87 centimeters. Hey, look it up here. We had measured that it was 10.8. We just calculated it's 10.87. We were really close. It was a good drawing. Now I have to take these same two numbers and I have to use to find the angle of here, all right, because that's this angle next to the start of my new triangle, the red one here. I have to go ahead and take the inverse tangent, -1, of the opposite over the adjacent. So what's the opposite from this angle? Oh, it's the 9.17. So I go ahead and put 9.17. I don't have to worry about the negative. And then I can put over the adjacent, which is adjacent here, because this side was opposite from that angle, adjacent to this, because the long side is always a hypotenuse, 5.83. So once again, I use those numbers here, just like I did over here. See, that's why they're so important, because they tell us pretty much everything. So now if I go ahead and I plug in, right, and realize you have to do, clear, you got to go second, right, and then tangent, because right above there you can see it says tan to the -1, all right? See, there's tan to the -1. The only way you get that yellow is by hitting that yellow button in a second. All right, so now, and you always have to do an inverse of one of the sine or cosine or tangents to find an angle. Always have to do the -1. So now I go 9.17 divided by, what, 5.83, and I get 57.55. So that's 57.55. So 57.55 is this angle right here. Now, I want to know from east. So you got to think, when I started up here, right, and I had to go all the way to this line, which is straight south. Oh, that's 270, right? So this line right here is 270. But then I don't want to know 270. I want to know this angle, right? All the way from east to here. So I got to go 270 minus 57.55 because I got to go backwards. So I take 270 minus 57.55, and this is going to tell me how far it is from east. That comes out to be 212.45. And hey, look at, I had 212 up there. Drawing was really good. Okay, but this is even more accurate. Degrees from east. So now we know exactly, and because we can see, right, that this number is equal to that number, pretty close, right? And 10.87 is really close to that. Our drawings match our math, right? That's the key. All right, there you go. That's how you do it. Thanks for watching.